very much close what everybody else is getting now. And pretty well settled that early man had been in Africa for at least 1.8 to 2 million years, and now we know it goes back much further.
The discoveries at Olduvai and Valsequillo were made at the same time and tested with the same dating methods. The African site changed human history, but the Mexican site was virtually forgotten.
As a Native American Studies professor and a person who teaches North American and Central American archaeology, one of the most aggravating, most exciting, and most inspiring sites, I think, for me to teach is a site called Valsequillo. It's important to me for several reasons. First of all, I've worked a lot in Mesoamerica. But secondly, it represents an absolute impossibility in North American archaeology. It's got three completely impossible things. The first component is basically, do we believe in our archaeologists? Do we believe that our archaeologists know what they're doing, how to dig, and their theory? And Valsequillo was dug by one of the foremost North American archaeologists many years ago. Her name was Cynthia Irwin Williams, passed away several years ago. I've worked with her in the Southwest, and everybody that I know respected her as one of the great dirt archaeologists and archaeological theoreticians. So the possibility that whatever she found at Valsequillo is not being real in terms of the context and the excavation of it, I can't see that as even a remote possibility. The other part is, as a scholar that likes to deal with dating and geochronology, there's an almost impossible contradiction between Cynthia Irwin Williams' discovery and the tephra chronology, the chronology of the overlying or associated volcanic deposits that have been dated many hundreds of thousands of years ago, way before we believe that the archaeological materials at Valsequillo could be made. And then you've got the third thing, the third issue, is the age of human beings coming into the New World. Of course, when I was a graduate student growing up, I was taught that Clovis was the earliest period. So we were looking at 11,005, maybe 12,000 years ago. Now we're pushing it back, of course, to the 15,000s. But certainly, I don't think there is a living archaeologist that would ever hold to the idea that people were here 200 or so thousand years ago. So what we have is not a dilemma, but what I've always called in my teaching a trilemma, a triangle. Any two of these components can be true. Cynthia can be right, and the dating can be right. An archaeological theory about the origin of people in the New World is wrong. The origin of people in the New World is right, and the dating is right, and therefore Cynthia Irwin Williams was wrong. Or Cynthia Irwin Williams is right, the origin and development of population in the New World is right, and the dating is wrong. But I just don't see how you can deal with that, because the dating was done by tephrochronologists that I respect and understand. The archaeology was done by archaeologists that I respect and understand. And as a practicing archaeologist, I am not going to go against archaeological method and theory that's stating basically that people had to come in somewhere after maybe 30,000 years ago. So this is a completely fascinating, completely aggravating, completely wonderful site to teach about. Because, as I said, any two can be right, but not all three. And so something, at some point, is going to have to give with reference to Valsequillo. And I don't know which it is. I just hope that my first choice would be to have Cynthia Irwin Williams be proven correct. Second choice would be I would hold to the tephrochronology and the geochronology of that. The one that I would feel the least affinity for and be willing to revise is the idea that people came into the New World relatively late.
The next step of the investigation was to determine which leg of the trilemma should be revised: the archaeology, the geochronology, or the theory of man's arrival in the New World. Marshall Payne decided to first examine the geochronology of the volcanic ash to find out if it was indeed 250,000 years old. He began the process by sending the original Huayatlaco reports to several geologists.
And back came the reports, and they all said the same thing. They said that the geology looks sound, but if you really want to be certain about this, you should use techniques that are available today that were not available 30 years ago. So we gathered a couple of 100 pounds of that material, and the Mexicans shipped that material up to Stanford University. And at Stanford, there was a man named Trevor Dumitru who agreed to reduce all these bags of material down to items which are datable.
The datable material is basically crystals of zircon, so they're little sand-sized crystals of the mineral zircon, and they have small amounts of uranium in them. And the decay of that uranium permits them to be used for determining ages of rocks.
Half of the material that he reduced was sent to a man who is now at the University of Idaho, who is an expert in fission tracking. The other half went to Caltech, to a man named Ken Farley, who is the originator and the expert on another dating system used in geology called uranium, thorium, helium dating.
In a zircon crystal, we can calculate the age of an eruption event if that zircon crystal occurs, for example, in a volcanic rock. The fission track dating technique concerns itself only with uranium inside that zircon, which is trapped at the time of crystallization, okay? And it looks at the uranium and the formation of these fission tracks due to the spontaneous atomic splitting or nuclear fission of the U-238 isotope. And those fission tracks form all the time, whether that crystal is in the magma and hot or at the surface and cold, okay? If that crystal is at the surface and cold, that crystal will accumulate fission tracks. They won't disappear due to heating. They'll just constantly add up through time. So the clock is the fission tracks accumulating. The ages that I have for this volcanic layer tell me that these rocks cannot be younger than about 250,000 years. My ages are minimum ages, not maximum ages. And so where my uncertainty in the results that I've generated resides, it's in why did I not get ages closer to Ken Farley's 400 to 500,000 year ages. I believe I have reasons, and I describe that both in the paper we intend to publish on this, and we've discussed this before. It has to do with the difficulty of working with these samples. But what I saw in terms of the number of these daughter product fission tracks, when I count, say, 100 of them, there are 100 there. And if those 100 tell me 250,000 years, then maybe there were another 50 that I didn't see for some reason, then that would add another 125,000 years and make it closer to 400,000 years. But I did not add 50 in accidentally. I saw 100 and there were 100 there. So my ages are a minimum. There's no way these rocks are younger than 250,000 years. Put it this way, there's no way the zircons are younger than 250,000 years.
You know, a criticism that is easily made is that the zircons within the layer are older material, that say a volcanic eruption occurs and it stirs up, you know, older material, and that cannot be directly constrained by the dating method. Now I think, you know, from what I've seen of this data, that doesn't appear to be the case.
In an effort to explain the seemingly impossible age of 250,000 years for the Huayatlaco ash, the latest fission track techniques were applied and corroborated Chuck Naser's earlier findings. The team next went to Caltech, where Ken Farley used his uranium-thorium-helium dating method. His test results were even more astounding.
Uranium-thorium-helium dating is a very old idea. It goes back to the discovery of the alpha particle, the first particle discovered to be a radioactive product. It's based on the idea that when uranium decays, it produces alpha particles at a known rate, and by measuring the amount of alpha particles that are present in a crystal, one can establish how long it's been since the helium began to accumulate in that crystal. I was contacted by Ray Donelick to work on a project that he was involved in, which was to establish the age of a volcanic unit by dating of zircons. And Ray Donelick had used the fission track method and proposed that I use the uranium-thorium-helium method to try to date the same formation. And the advantage of the uranium-thorium-helium system relative to the fission track system is that there are a lot more alpha particles produced than there are fission tracks produced, and so you get a much larger signal, which is important when one is trying to date very young samples. So I was sent zircon separates, which I analyzed here in my lab. The analysis involves picking out a few crystals from the population of crystals I was sent, heating these crystals to 1300 degrees C with a laser or with a resistance furnace. The helium comes out of the crystals at that temperature by diffusion. We then retrieve the crystals from the vacuum furnace after the helium is analyzed, retrieve them from the furnace, dissolve them, and analyze them for uranium and thorium by inductively coupled plasma mass spectrometry.
I exacted blood oath promises from these scientists that they would not communicate with each other until I had their results in my hand. And they agreed to do this, and in fact, that's what they did.
The zircon crystals were sent to me blind. All I was told was that the crystals were likely to be young, which is an important thing to know when one sets about making an analysis. One needs to know about what to expect just to figure out how much sample to analyze. So I was prepared for the samples to be young, analyzed the samples, produced an age which was between 400 and 500,000 years, and that is slightly older than the age that was obtained by Ray Donelick by the fission track method. And I think within the uncertainties of these measurements, that's probably not a big surprise. In particular, the fission track method has relatively limited resolution at young ages. So the ages are somewhat different, but I don't think they are different beyond a reasonable analytical error. Whether or not that agrees in detail with the fission track method, you'd have to ask Ray Donelick about what the origin of his uncertainties are.
I do have certain reservations about the data. I'm quite convinced that Ken Farley's ages are probably closer to the true age of this volcanic rock than my ages. And that is largely due to the higher precision of his methods, and he was able to reproduce his results more closely than I was. I tried to do reproduction of my results, but these samples are so difficult to work with for fission track dating methods that we're right on the edge of whether we can analyze them or not.
So the date that I've been using as a compromise between the two is 300,000 years old. And if I had to bump that someplace, it would be up.
To explain to you why I think I would favor the helium age over the fission track age is for every fission decay that he can count, there are about 10 to the 7, 10 million alpha particles produced. And so since he has very few particles, very few tracks to count, in comparison to what I have, I've got 10 million more that I can measure.
Since the age of the ash appears to test to at least 250,000 years, the next question is, has the relationship between the Huayatlaco ash and the artifacts been properly identified? The team examines Leg 2, of the trilemma, the archaeology. Throughout the years that Cynthia was excavating, her team developed a geological model that showed that all the levels of accumulated sediment were laid down successively on top of one another, like a layer cake. All the artifacts and associated bones were excavated from strata below the Huayatlaco ash. Geologist Hal Maldi went back to the site to retest the stratigraphy.
So I didn't go back until 1973, and our purpose then was to do a geologic excavation, not an archaeological excavation. So maybe the best way to explain that is to look at this photograph, which was taken in 1973, looking at the Huayatlaco site on the eastern side of the Tutela Peninsula. Here we're looking to the south. And in the photograph we can see the area which Cynthia had excavated in the early 60s, and where she found artifacts and certain bone remains. I acted primarily as a surveyor, and Virginia Steen McIntyre did some sampling, and the primary investigator was Roald Fryxell, who was a professor at Washington State University. And Fryxell had had a lot of experience working with archaeological sites. So he was skillful in identifying what we call stratigraphic units, or individual lithologies, and units of a particular characteristic. And he drew those in his profile sketches, sort of like looking at the wall of a canyon. He would draw the individual layers that could be seen. He also did a technique that is very common among soil scientists, namely he took monoliths. These would be, so to speak, cemented to planks of wood and therefore preserve a portion, a vertical section in the bedding that was seen in these trenches. The bottom line on this is that we were trying to determine whether, strictly on the basis of the stratigraphy that would be exposed in these trenches, whether there was continuity from the place where Cynthia had excavated in the 60s and the uppermost part of the exposed geology. And in fact, that was the result. We found that it was layer after layer after layer, with no interruption, no discontinuities, no places where there was any downcutting. A simple set of individual units, one on top of the other, from where Cynthia had dug all the way up to the top of the section. So that really finished our 1973 investigation.
Now, when you say you check the continuity, does that mean that the layer with the artifacts, which was under the layer with the volcanic ash, that the artifact layer is older than the volcanic ash layer?
Layers of sediment are laid down one on top of the other, unless there's some aspect of dissection in the meantime. And in this case, it's simply one leaf of the geologic time on another leaf of the geologic time.
In the first leg of the trilemma, the geochronology says the age of the Huayatlaco ash was at least 250,000 years old, and some tests gave an age of over 1 million years. The second leg, the archaeology, bears out that the artifacts appear to have been found in a sequence of strata, which is entirely overlaid by the Huayatlaco ash. If these two legs of the trilemma are correct, this means that modern bifacial spear points were made in the New World, 250,000 years ago. It's time to examine the third leg of the trilemma, the theory of man's arrival in the Americas. According to the prevailing archaeological model, modern man occupied North America around 15,000 years ago, and migrated into South America around 12,000 years ago. To date, most of the evidence found by archaeologists supports this scenario. But what happens when evidence is found that does not?
If you can imagine that 22,000-year-old dates were controversial, put another 0 on that, and all of a sudden we're coming out with really nice spear points that nowhere else in the world were found at that antiquity. This was a huge problem. So Cynthia really didn't know what was going on. She wondered about the nature of the dates, how this could possibly be credible. She thought the dates were silly, out of the range of possibility, and she blamed the dating technique as not indicative of the dates that were coming out. And she discussed these problems with colleagues of hers, including Marie Wormington. And there are some letters that have survived that discuss this type of quandary that she was in. I recently got a letter from Hal Maldi with some incredibly wild uranium dates on the Valsequillo material. I don't see how we can take them seriously since they conflict with the archaeology, with his own geologic correlations, and with a couple of C14 dates. However, God help us, he wants to publish them right away. I'm enclosing a copy of Hal's letter and my reply. Needless to say, any restraint you can exercise on him would be greatly appreciated. All we need to do at this point is to put that stuff in print, and every reputable prehistorian in the country will be rolling in the aisles.
In the audience was a geophysicist by the name of Barney Szabo. He came up to me after hearing my talk and said, I'm doing research on a dating method called uranium series dating. Do you have some samples that I could work with? When he got these results, it turns out that the Valsequillo material seemed to be about 250,000 years old. And when I told Cynthia Irwin-Williams about this, she sort of blew her top. She couldn't believe that this was so, and she thought that it was improper to publish the results. But Barney was very concerned about getting this information out into the scientific world for review. So as a result of several conferences, Cynthia agreed that we could publish this, but in a place which would not be seen ordinarily by archaeologists, which is a rather peculiar ploy. But and meanwhile, she would also provide sort of an internal rebuttal. Part of my confusion at this time was that it seemed very difficult for me to rationalize these old dates with my understanding even of the archaeological context. So that led to the use of the word dilemma in the paper that we used to announce to the scientific world these old dates determined by the uranium series method. I think as a result of that, Cynthia really gave up on the site. 1966 was the last time she was down there, and she, let us say, washed her hands of doing any further publication. We got no feedback from her about anything further about her results beyond what she had already published, and things really came to a standstill.
As a result of these controversial dates, Cynthia Irwin-Williams never returned to Valsequillo. All of her artifacts and most of her field notes have vanished. Juan Armenta was forbidden to return to the site, and all his artifacts were confiscated. Irwin-Williams never published the final results of her 6 years of fieldwork. So which of the three legs is wrong? Some experts in the field believe they have found an explanation that could solve the mystery of the trilemma. Geologists call it an unconformity. Dr. Michael Waters is the director of the Center for the Study of the First Americans. He has worked on more than 50 archaeological field projects and is well known for his expertise in geoarchaeology.
Valsequillo and Huayatlaca always intrigued me because it was one of the localities that had the possibility of strong evidence for pre-Clovis occupation in the Americas. And so I read about the excavations that were done in 62, 64, and 66 by Irwin Williams. I even met Irwin Williams a few times. And then I read about the work that was done in 73, and then discovered about the research that you funded